My name is Krysta White. I'm from Texas Wesleyan University, and this is my PI.
Hi, my name is Dr. Phong Ngo, and I'm a professor at Texas Wesleyan University.
So what was your first paid analytical chemistry experience?
Professionally, I was a forensic scientist for 2 different crime labs, and there I did a lot of LCMS, on forensic evidence, mostly on firearms evidence, sometimes some drug evidence. So that was really my first paid professional job as an analytical chemist, but my training is actually in biochemistry, so that's why I was able to get into forensics and do that kind of thing. So,
what is your current job as an analytical?
So again, my training is in actually biochemistry, but I was hired at Texas Wesleyan to be the instrumental analysis and analytical chemistry professor, and also the forensic science professor as well. And so I guess in all my training at school and also training at my job before I came to Texas Wesleyan kind of prepared me for that kind of what they wanted me to do at Texas Wesleyan. So yeah.
So what analytical research projects do you facilitate?
So I do direct all of the analytical research at the school, and so I guess the 2 current ones are the quantitative distance determination experiments research project, where we're trying to determine how far a target is from a gunshot from a firearm when a gun is discharged. And the reason why that's important is because distance of muzzle to target can determine whether or not a person was either shot by another person or shot themselves, and so it corroborates stories that are at scenes of shooting scenes. And so traditionally it's always been a very subjective thing where we look at patterns that are test fires at known distances, and we try to match them with what evidence it looks like for the GSR patterns or gunshot residue patterns. But in the recent years, we've been trying to move away from subjectivity in forensic sciences and go towards more objectivity. So we are applying a calibration curve to the distance, and so now we can correlate a concentration of GSR to an actual distance. And so that's what we're doing in one research project. Another one we're working on too are separations of synthetic cannabinoids using LCMS, and then also we are doing another project where we're trying to correlate expression of cortisol producing enzymes with cortisol levels in blood tests using the LCMS. So we have some pretty interesting kind of analytical projects going on.
So what's your favorite instrument to use in our lab?
I would have to say the LCMS. That's probably my favorite. I've been really wanting. I had one at my previous school, and when they told me I could get one here at Texas Wesleyan, I'm like, I'm there. And so I bought the best one we could get, but still maintaining the kind of like the software integrity, where all of our instruments are Thermo Fisher instruments, so they all run on Chromium. So I'm pretty excited about the LCMS. It's going to open up a lot of doors for us, and also I'm also excited about maybe getting a dynamic rate detector for LC as well. So, but yeah.
And my last question is, what motivates you to go to work every day?
To be honest, I tell my students that they give me gray hairs, but and there's evidence of this. As a forensic scientist, there's evidence that they give me gray hairs. But really, going to work and seeing them make connections with the chemical concepts that we teach them in the lower level classes, and then having them be able to make connections with like application in the real world is really what makes me happy. Especially since a lot of my students they want to be forensic scientists, and what they do really have an immediate impact on society, and so a lot of the research we do is so fundamental. There's like 10 years down the road, you actually get some kind of practical thing. But for forensic scientists, the stuff you do will happen immediately, right? And the impact you have on society will happen immediately. And so that's really what makes me happy, is when I see them making these connections, and then they're able to actually use these skills and then go to trial and testify and show their expertise and make an impact in people's lives.
Well, thank you.
Thank you, Krysta.